Welcome back all. So we today we will look at the in last session we stopped at the 2023, the latest gate question paper with this question regarding the Balmer series of lines. So we will in this session we will finish 2023. We will we'll be working out some of the questions in details, and some questions we will be just skipping, and we will move on to the 2022 question paper also. So this session will have both like 2023 and 2022 question papers. Okay, so with that we can start. So this is the first question. It's basic vector differentiation, etc. That kind of question. So question is consider given a vector field is given. It is like velocities of points on a thin horizontal disk. The radius of the disk is given, moving anti-clockwise with uniform angular speed. So I have just shown schematically here. The angular velocity is given as omega 2 radians per second, and the axis is given. It is passing through the center like this. So this will be the axis of rotation, and v is the magnitude of that rotation. Then just the question is to pick up which of the options is correct. Okay, so you are provided with the gradient and divergence, curl, etc. These relations in the spherical polar coordinates, not spherical polar, cylindrical coordinates, because we have this kind of cylindrical symmetry here. It's a rotation about axis, so we should be using cylindrical. Okay, so without doing too much calculation, I will show you how to, like in this kind of questions, how we can make a choice. Okay, so the first option is that the gradient of v is to r cap. So one thing we can actually, like this question, this particular option, we can always because this is like this purely a physical argument. We have a rotation here, which is like it's a curl. So the physical idea between the curl of something is it's a rotation about some axis. How much field is rotating about a given axis, like that. So here it is given that the velocity itself is rotating about an axis. It's the angular velocity kind of. So for this kind of things, it should be having a non-zero curve always, and it can be seen that we already know that gradient cannot, curl cannot diverge. This relation is that del dot of del v, del cross v is 0. So when there is something curling around a point, and if you take the divergence of that quantity, you will get 0. So that option, straightforward. No need to do any calculation. So this one you can directly omit. This one del dot v, it should be 0 actually. So this one, given it's a non-zero quantity, we are able to, we can go for this is a wrong answer. Okay, so what about the other options? Now which one is easier one? Okay, so curl of v is 4z. This one is like v, again v, as I told, the velocity is rotating about an axis, so it should be having a non-zero curl, right? So we can actually use these relations here. Del cross a will be given by this. So here if you put this v is a vector which is curling around an axis about the z axis. Given here is it's a z axis, right? Yeah, so the axis passing through, it's an we can take, maybe we can take it as the, like in the cylindrical coordinates, this will be, you have to take this as this will be the z axis, and you have s will be going this way, and theta, and you have phi will be curling around something like this. So this is how you choose the coordinates in the cylindrical coordinates. Okay, so given that we know that, so it is given that it's a pure curl around, it's a curling around, the velocity is turning around the z axis. So that means it will not be having any, like, there is no there is no motion in the z direction, and also there is no motion in the s axis. S and z axis will not have any components. So that means your Vz and Vs, Vz and Vs both are 0. Vz and Vs both will be 0, and that means you will get this is 0, and this will also go to 0. And also, if you look at AFI will not depend on dou z, because it's curling around, it's a purely completing it's a curling around about this axis. There is no z dependence for AFI term, so this complete thing will be 0. And also this here also dou az, since there is no az part, this will be also going to 0. So the only contributing term will be this. Here also this term will be 0 again, due to the fact that Vz, there is no component of velocity in the s component and z component. So only contributing term will be this particular term. So we just have to calculate this term. I have written down here. So we have to take, since it's a uniform angular velocity around this axis, we can take simply the component v phi as v phi equals s omega. Omega is given angular velocity here. Okay, so taking that, you simply take this derivative 1 by s dou by dou s v phi. So putting that term, you will get s square omega here, and taking the derivative, you will get 2 omega. And here it is provided that omega is 2 radians per second, so that means 2 omega is 4 radians per second. So that's how you get a 4 here. And the direction, but should be the direction of this curve. So since this curling around this axis, this particular z axis, so you should be having curl of v is 4z. Okay, so this is the right answer. So what about the other two? We look at the curl, the gradient. Gradient is given here, dou f by dou s, and this particular equation you have to use. Again, you have to be in this particular case, you know what is the here. The v is given as a magnitude of the velocity, right? So the gradient is taken of the gradient of the magnitude of or it's a speed, a gradient of the speed, like that. So v will be the magnitude of velocity, that is s omega, as we took before. Taking the gradient, you differentiate only with respect to the s component, because there is no phi or all this contribution, right? Dou by dou s phi and z, this all will be 0. So you will be only having s differential with respect to s, that will give you omega s cap. You have s cap here. Okay, so that will give you the gradient of this velocity vector as 2r cap. R is basically s here, the radially outward direction. So there is little confusion, since s phi z is given here and r theta is given here. So you have to take the axis, choose the axis in order to get this kind of setup. Okay, so that will give you the gradient of v will be 2r cap. So this is also right answer. What about the last choice? So del square is a Laplacian of again the velocity magnitude of magnitude of velocity or the speed. the Laplacian of the velocity speed. Again you apply this this particular Laplacian. You will not have any phi and z dependence, so you simply have s dependence. So again taking this v phi, the s component of velocity, is not the s component, the magnitude of velocity s omega, you simply take this differential 1 by s of dou by dou s with respect to this, and substituting for v as s omega, you will get simply omega by s. So if you put the value omega, it is given here that it is 2 radian per second, and it is given at r equal to 1.5. So you simply take 2 divided by 3 by 2, which is 4 by 3, and 4 by 3 is 4 by 3, this is given. Del square is 4 by 3 at r equal to 1.5, and this will be also right, and this will be also right choice. So the only wrong option is option B, due to this particular, like there is no, a curve cannot diverge. So all the other choices you actually have to do some calculations to get this, but not very difficult, but some basic understanding will give you this kind of. So the right answer is A, C and D. So this is a multiple choice question. You have to choose all 3 questions to get the full marks. Okay, so next question. The question is for a non-relativistic electron in solid, different energy dispersion relations schematically shown in these plots. So these are basically the EK, like how the energy varies with wave vector k. It's a dispersion relation. It's called a dispersion. It's shown here. The question is that which of the following option is correct? So you have to So what is m star? Basically is the effective mass. So you have to know what is effective mass and how to get this effective mass from dispersion relation. So it's a very easy question actually. M star is the effective mass is given as h square divided into 1 by del square E by dou k square. So it's the second derivative of energy, the dispersion relation. You take the dispersion relation E of k, E will be a function of k, and take the second derivative and take the inverse. Or basically the idea is that the effective mass is inversely proportional to the second derivative of dispersion relation. So here if you look at this, which one will be having the most higher, the blue curve will be having higher derivative, second derivative, right? It's a very concave kind of, the slope is very high, and this one will be having the lower slope. So that means since your effective mass is inversely proportional to the second derivative, this one MC will be having, the C particle will be having the least effective mass, and the A will be having the highest, as shown here, and B is in. So that's all this easy question. You only have to remember what is the relation effective of effective mass with respect to the given the dispersion relation E as a function of k. It's also, you might be also seen this in terms of like omega equals omega, but so omega is a function of k. This is also called dispersion relation, and E is basically h cut omega. These relations you can use to convert this into energy and angular frequency, etc. So usually when electromagnetic waves are discussed, this particular form is given. So in condensed matter, usually people give like E as E function of k in this form. So both of them are dispersion relation. You have to be aware of this. So that the right answer is option B, with C being the lowest effective mass and A being the highest effective mass. Okay, so next. The atomic number of an atom is 6. What is the spectroscopy notation of this? ground state, so it should be noted. They are asking for ground state according to the Hund's rule of maximum multiplicity. Okay, so 6 atoms, 6 atomic number is carbon atom. 2 you have like 1s2, 2s2, 2p2 kind of arrangement. Yeah, I'm showing how to find out the spectroscopic notation of given atomic arrangement. So this is a standard spectroscopic notation, how to represent this. So this n is usually omitted. You need not to actually write down what is n. Here also you can see there is no n is given. There is nothing given here. So n can be omitted. It's a number of in which level, the principal quantum number of the excited, the electron in which the highest energy electron is residing. That's n value. So n is a principal quantum number, s is a total spin quantum, not just a single spin, single electron spin, but the total spin of the atom. And L is L actually denotes the orbital angular momentum of the state of the atomic arrangement. So the standard is to denote S with total L equal to 0, P with L equal to 1, D with L equal to 2, so on. And the total angular momentum quantum number is J. J is basically L plus. You add spin quantum number and orbital quantum number in the respective fashion. Usually that's how we calculate total angular momentum. So in this particular case, you have 6 electron atom, it's a carbon atom. You take the outermost shell with this 2p2, you have p orbital with 2 electrons in this kind of arrangement. So the total, first one to calculate is the total spin quantum number, which is like half. Each electron will be having half and half. This is spin half particle electron, and this is also spin half particle. So you have each one having spin half. So you simply add them, you will get total 1. So that will give you total S is 1. Now in the notation we actually did not we don't give S, but we give 2s plus 1, the multiplicity of that particular arrangement state, spin state. So that is 2s plus 1, which is 3 here. Now L, what is L? Here it's basically the sum of ML, the magnetic quantum numbers of orbitals. So plus we have plus 1, 0, minus 1, etc. So if you sum 1 and 0, you will get 1. 0 and 1, that will give you the total angular orbital angular momentum. But it's given in number. Usually we denote it with according to this particular rule, with symbols, alphabets. So S equal to 1, L equal to 1 denotes the P, P notation. So that will give you P here. Instead of L, you will have P here. Now what about J, total angular? J, you can, it can, when we add angular momentum vectors, angular momentum quantum numbers, there are several number of outcomes you can get. Several outcomes you can get up to L plus S from L minus S, mod of L minus S to mod of L plus S. These many configurations are there. So here L is 1 and S is 3. So L plus S is basically, sorry, I have made a mistake here. 3 plus 1. 3 plus 1 is 4. And 3, yeah, yes, 3 is this is correct. S is 1 here, this is 2s plus 1. So we have to take S and L. S is 1 and L is 1. S 1, P 1. Okay, now it's fine. So L plus S is 2 and L minus S is 0. So there are three configurations possible: 2, 1, and 0. So since the ground state is asked, you should be having the lowest possible energy state, which is the 0 state. So the ground state, it will be denoted with the term symbol 3p0. So the right answer is 3p0. Given. Okay, so moving on to the next problem. H is the Hamiltonian, L is the total orbital angular momentum, and Lz is the Z component. So the usual angular momentum quantum mechanics, we deal with this kind of operators: Hamiltonian angular momentum, and angular momentum has the total, it's a magnitude and the Z component. So here L vector L is the total angular momentum. So oneness state of hydrogen atom in the non-relativity formalism is an eigenfunction of which of the following eigens? So this is an easy question. You should be knowing H, L square, and Lz. So what is the hydrogen atom? H eigenvalues are like you should be knowing 13.6 divided by n square for n principal quantum number n state, and L square quantum values are L into L plus 1 h square, and Lz mh square. So where this n, L, and m, these are quantum numbers: the principal quantum number, azimuthal quantum number, and magnetic quantum number. And you have one more in the non-relativistic. In the relativistic case, you will get spin quantum number also. Since here it is only asked non-relativistic case, so we should be taking only 3 quantum numbers, n, L, and m. Okay, so why let's just which one of the following set of operators should be the eigenfunction? The given state, the oneness state of the hydrogen atom, which is the ground state, it's an eigenfunction for each of these. So this is obviously true. This is also true, L square, Lz. So I think this is not a sorry, as I jumbled these questions, this is not a multiple choice question. So be aware of the fact that there are multiple choice questions and also single. You have to choose either only one option. Also that there are 2 types of questions. So in this particular question, they are asking for one option only. It's not a multiple choice question. So this is also true actually, but since this is the highest, like this is subset of this, so this one is the most general case, and this is also true, H and L. But L, this you should be knowing. Vector L is basically you have the X component. It's basically a vector Lx, Ly, and Lz. Since they do not commute like Lx and Ly or Lz, whatever. If you measure one of the component L, if you measure Lx, then you are not in an eigenstate of Ly like that. So only this gives you the most general operators, set of operators. So that is the right answer. Okay, next. Under parity and time reversal transformation, which are the following statement is true about electric dipole moment P and magnetic dipole moment B. Okay, so this you only need a basic classical notions of what are these quantities, what is the magnetic mode dipole moment and what is electric dipole moment. So electric dipole moment is defined as charge time position. If you have 2 separated charges, or usually if this is the origin and there is a charge here, the dipole moment is usually defined as QR, like that. If there are several charges, it will be some over QI, RI, like that. So whatever, it contains a position vector R. So the option questions are like P is odd. They are asking whether they are odd or even under parity operation, parity and time reversal. Okay, P is they are asking P parity and time reversal property of mu. Okay, so P, if you look at, since it contains a position vector, parity, what parity does, like if P is the parity operation, it flips R to minus R, right? That you should be remembering, like it flips the coordinate position vector from R to minus R. It's a space inversion. So since it contains R, if you act parity on P, capital P, or the magnetic dipole or electric dipole moment P, it will make it will go to minus P. So capital P. I am denoting vector P as the electric dipole moment. This will go to minus P due to the fact that it contains a position vector. So P is obviously, this kind of operators are called odd operators. These are odd under parity operation. So this is true. This is also given P is odd under parity, but we have to check whether mu. Now comes mu. Mu is the magnetic dipole moment. Now usual definition is a classical notion. You can, if you have a wire, loop of wire carrying a current I with the area A, then the magnetic moment is defined as like mu equals IA with the direction perpendicular to the direction of the plane. Okay, so since it contains I, which contains a time, so what time reversal does is that it's a tau operator, we denote it with tau. It flips t to minus t. So it flips time basically. So since it contains a time, it will take I to minus I. The current will be like it's reversed. So that means T is odd under, mu is odd under parity. Mu is odd under parity, time reversal, and P is odd under parity. Now that's the right answer. So you will get option A. Every other option is containing other options. So option A is the right answer. So what happens if I apply time reversal to the P operator, P like my alternative dipole? Nothing happens because it does not have any time dependence. So P is even under time reversal because it does not change the sign. Okay, so what even means, it's same sign. Odd means it flips the sign. Okay, so this question I am flipping. I am skipping. In future I will be coming to this. I am not able to get the answer for this. Now several questions I have discussed. This not much derivations or something. So which of the following are the correct options for the Joule-Thomson effect? So Joule-Thomson effect, you can simply Google, you will see that. I don't know whether you have in the syllabus. I did not have actually. So basically you pump some fluid through some narrow hole, something like that. So yeah, the temperature change happens to a real gas when it is forced through a porous plug. So it's a small hole, you can imagine like that, while keeping it insulated from the environment. So there is no heat exchange actually happening. So the question, which of the following are correct? The options are: is the isoentropic process, it's an isoenthalpic process. It can result in cooling as well as heating. For an ideal gas, it is always result in cooling. Like so, this I actually googled about this, and this is what I found. Enthalpy actually remains this unchanged during this process. So it's an isoenthalpic process, the Joule-Thomson effect. So temperature can change, but it's the enthalpy, not the. There is a heat exchange can happen, but that does not mean enthalpy can change. It remains. Enthalpy is more than just heat energy. So the enthalpy will remain unchanged under this Joule-Thomson effect, and since the temperature change, depends on how much pressurized you the gas, and it depends on the details of the system. So it can actually result in cooling as well as heating. An ideal gas, I did not see it's a effect seen for the real gas. So ideal gas, whether it shows Joule-Thomson effect is something I don't know. The right answers are anyway in the if you check the answer key also, it's B and C. Okay, next question. This kind of question I'm not actually confident about this, but I am just marking the right answers. The Deuteron is bound state. The following sequence. Just read through these options. Yeah, the GM counter is a device to detect alpha beta in any radiation. It's a cylindrical tube. You might have learned about this at least in some degree class or something. You have a potential difference between central wire and cylindrical kind of electrode here. There is a potential difference between the positive and the ground is there. So the question is again is pick out the true statement, which is which are there can be several statements. Argon is used so that ambient light coming from the surrounding do not produce any signal. These are the I marked from the answer key. Either you have to like these are like a very detailed kind of some specific kind of questions. So you have to simply remember these kind of questions. Just have an idea of what are these devices. So last option is something I can think. Like electric field strength decreases from axis to the edge, or it increases. This is something you can. So if you have some arrangement like this, you have central node here, and you have a surrounding electrode in the cylindrical fashion here. So this should be the electric field lines, right? So you might have you should have remembering like when electric field lines are closer, they are strong. The magnitude should be strong, and when they are farther apart, the magnitude is small. So the center should be having stronger electric field, and as you go radially outward, the strength decreases. So C is the right answer. So A, B, C are the right answers. Okay, so in this particular one, I am not discussing 62, 633, but only 64. These are the options I got from the answer keys. Maybe I will be in future sessions. I will try to. As of now, I am not confident about the answers. 64, two identical non-interacting helium atoms are distributed among 4 different energy levels. The probability that they occupy different energy levels are P. Similarly, there are 3 again 3 helium, but only having 3. One proton, one neutron is missing. They are distributed among 4 different non-net energy levels and probability Q. So what is the ratio of P by Q? So this is basically the identification is that this particular I googled about this. This is what I found. Helium 4 is a boson. You can treat it as a boson, and helium 3 is a Fermat. So basically they obey different statistics. That's the basic idea of this question. So you can guess whenever this kind of question is they should be asking some kind of distribution, how like only when their distribution is the same, then there is no point in asking this kind of question. So when there are different statistics governing them, it's a non-trivial question actually. Okay, so let's work out how so what was P actually? P is the probability that they occupy different energy levels. There are 2 helium, 2 bosons in 4. That's the only thing you have to take away. 2 bosons in 4 different energy levels. So how you can distribute them? That's the question. What is the value of P? So P is simply the state with different energy. Also it is given that they occupy different energy levels. So these are my energy levels. So what are the possibilities that I can distribute them? If I have 4 levels, I can. Since these are bosons, I can put anywhere, right? These are all valid state. Also, you can put like different energy levels. One here, and one here, like that. So there are total 10 possible states. Actually, if you took this state and if you just swap them, like this boson here and this boson here, does not matter because these are indistinguishable particle. So whether you put this one here and this one here does not matter. So there is only one state. You can count it at only one as one state. So that give you this 10 state, 10 total 10 states, and you simply count how many of them are in these states, how many of them are in different states, different energy levels. So you will get 6. So P, the value of P is 6 by 10. Similarly, the case of helium 3, because it's a fermion, again they are occupying different energy levels in 2 fermions in 4 energy levels. Since these are fermions, they cannot occupy in the same energy level due to the exclusion principle. So you anyway have to put them in different levels. So that means Q is 1. So that simply give you P by Q is 6 by 10, 0.6. That's how you get the answer 0.6. Okay, so this is a nice question actually, but you have to make this identification like helium 4 is boson and helium 3 is fermion. Okay, so next question also I am not discussing. Okay, following whatever questions come on, I skip through them. Most appropriate matching between column 1 and column 2. So just check, these are easy questions. I have marked the questions. These are from the answer key which I have already shared. All these answers you can get from the answer key also. So there are numerical questions also. These nuclear questions anyway I am not confident about. So I am skipping all these questions for now. Okay, this particular question, one hint I can give you is that 4x4 matrix M has a property M dagger is minus M, which means if M dagger equals M, it's called a Hermitian, which is having only real eigenvalues. When this is happens, this is called an anti-Hermitian. Yeah, it's written here, it's a anti-Hermitian, and it should be having only purely imaginary eigenvalues, not any real eigenvalues are not possible. So the question is which of them are the possible eigenvalues. The trace should be also 0, that means this option B is the right answer. And article, okay, so this is the end of the, we have 15 more minutes. Okay, then I am quickly going through the next. We will start the 2022 previous year question papers. Yes. Okay, so as before, I will start with the GA question, general aptitude questions. Sorry, so you should dash when to say dash. You should know when to say no. Yes, right. You should be always knowing. Two straight lines pass through origin x0, y0 equals 0, 0. One of them pass through x1. There are 2 points given through which a straight line pass. Okay, one pass through 1, 3 and one pass through 0, 0 and 1, 2. So like this, you have this line and this line. What's the area of area enclosed between the straight lines in the interval 0? I will just redraw here. You have this one line and another line. Make sure the identification that both lines are actually in the same, like this is 1, 3 and this is 1, 2. Okay, so you have the same x coordinate here. So there is a triangle hiding. Okay, so what is the area enclosed between the lines? Yeah, between the lines. So they are asking only for this region. This is not required. Okay, How to find out? So easiest method, you find out the area of this big triangle and you find out the area of this triangle and subtract. Area of the triangle is basically RBH. If you forget. The first triangle you have area 3 by 2. So ABD is 3 by 2. ACD is 1. So 3 by 2 minus 1, you get half. Half is the right answer. Okay, so if P by Q is 1 by 2, Q by R is 4 by 3 and R by S is 4 by 5 and U is 50% more than S. So U is not in this list, but it's a P, Q, R, S and U. So fifth number, what is the ratio? P is to U. Okay, the first number and the last given number. It's not difficult one. P by Q is 1 by 2 given, that means Q is 2P. Q by R equal 4 by 3, that means, so just go step by step. Q is 4R by 3 and you can actually use this relation. This is the first relation, you put it here. So the 4R by 3 is 2P. So basically you want what is P, what is the relation connecting P and U. Now R is given in terms of P. In the next one, R by S is given. So now using this relation here, you will get S is 15 by 8 P. Now the last step, U is 50% more than S. So that means it's a 3 by 2, like it's a 1.5 times than S. So if you have S times 1.5, that much is your U. Okay, you use 3 by 2 times S. They are just saying it indirectly. This statement basically means U equal to 3 by 2. Yes. So they are asking what is the relation between P and U. P is here and U is here. Now you again put connect them. 2 by 3 U equals 15 by 8 P, the final relation. That will give you P by U is 16 by 45 and that will give you the right answer, 16 by 45. Okay, so these kind of questions, I mean, if you practice, you can maintain time. You can take more time for the like physics questions more, and this GA questions you can, if you prepare, I mean, if you try many question paper, you can do the faster. Okay, so given the statements, P is the sister of Q. I have diagrammatically shown here. These kind of relations are also a little bit confusing. You make this kind of diagrams. P is sister of Q. P is the sister of Q, and Q is the husband of R. Q is the husband of R. R is the mother of S. R is the mother of S. T is the husband of P. Okay. Based on the above information, T is dash of S. T and S. What's the relation between them? Okay. So mother, husband, you. If you just analyze this question, you can see that he is an angle. T is the angle of S. Okay. Yes, then in the following diagram, the point R is a very tricky, but it's a nice question actually. R is the center of the circle. The lines PQ and ZB. PQ and ZB is here. This is ZB and PQ is this. Okay. The relation among the areas of square is PXWR. PXWR, this one, and RUVZ. RUVZ, this one, and this one. SPT. Yes. Okay, so they have actually, you might have seen this kind of diagram, like if you have a right angle triangle, you have a square, sorry, a intended as square here, square, square, square. If this is A, this is B, this is C. Say area, okay, maybe A square, B square, C square, then Pythagoras theorem tells you A square plus B square equals C square. So same thing goes here, but you have to make the identification that this area and this area are the same. How to do that? So this is the center and this is a right angle triangle, right? So this should be radius. So this is a radius, means this is also radius. Again, it's a right angle triangle. So this have an area of r square and this also have an area r square. Yeah, because PQ and ZB are tangential. So PQ is tangential, means this is this, and RB. Sorry, ZB is this. Yes, that means this 4 lines. 3 lines. These are all radius. Only a radius and a tangential makes a 90 degree between them. That means you have the now just look, area of SPQT is the area of this minus area of this. So that's the right answer. Pythagoras theorem. Okay, so this one I'm skipping. Just read the passage and go through. The P invested 5,000 per month for 6 months of the year, and Q invested X. Profit is shared in proportion to total investment made in that year. If at the end of the investment year Q receives 4/9 of the total profit, what is the value of X? Okay, so just write how much they invested. P invested 5,000 per month for 6 months, so that means 3,000 rupees he invested. Q invested X per month for 8 months, so 8x. So that means P by Q or Q by P is that. Okay, the profit is shared in the end of the. Yeah, so at the end of the investment, Q receives 4/9 of the total profit. Okay, if total profit is 9, then Q receives 4 and P receives 5/9. P receives more. Okay, so total is 9 and 5 parts for P and 4 parts for Q. That's how you get Q by 9 equals 4/5 here, because you have the relation Q gets 4/9 and P gets 5/9 from this, and that is equal to, that is based on the fact that what they told is the shared in proportion to the total investment, how much they invested, right? So that means Q by P 8x divided by 30,000. So that just rearranging you will get it. This is 3,000. 3,000 is the answer. Okay, so yeah, this one, the chart is given, frequency chart. From the data presented above, which of the following is correct? Okay, so mean, mode, median, these are, if you remember, mean is what? Mean is the average. So mean is usually sum or Pi, Xi. PIs are the probability for occurrence and Xi are the outcomes. Mode means it's most frequent. Which one has the most frequency? That's the mode. And median is just highest average between highest and lowest by 2. It's just a middle value maybe. So in this, which one are the easiest? Median is easy. So you have the lowest value 3 and highest value 9. That will give you 3 plus 9 by 2. 6 is your median. Mod is the highest frequency. So you have 7 here. So that will give you. Mean is the tricky one. Just count them and add. Is the easiest way. I cannot tell you any other way. So mean is basically you add all these numbers 9, how much times they repeated, divided by the total occurrence 3 plus yeah. So 3 happened 3 times, that means 9. So on. That's how I'm getting this. 4 happened 9 times, that will give you 36. That's how I'm getting 36 here. Like that, you simply add them and divide with the total values, like how many occurrence are there, 3 plus 9 plus, that will give you the probability of occurrence, right? So this calculation you have to do, and the more the time you keep practicing this question, this kind of question, you can attain some pace. So if you calculate this thing, you will get 5.84. That will give you your which one is the highest? Mod is the highest one. Lowest one is your mean. Yeah. And median is in between. Yes, option B. This is the right answer. Because you have 7 greater than 6 greater than 5.84. Yes. Okay. This is just a puzzle kind of question. I'm skipping. This one is actually given marks to all in the key. Okay, so these are the physics questions now. Let me check how much time do I have. I will keep all the sessions to 1 hour only. Yeah, I think I have 8 more minutes. Yes, so for normal Zeeman lines. So now these are the physics questions. General aptitude is over. Again, I am going in some jumbled order fashion. The questions that I found easier for me, I will be doing first, and I will try to do the whatever leftover questions in the last sessions. Okay, so for normal Zeeman lines observed parallel and perpendicular to the magnetic field applied to an atom, which of the following statements are again a true statement picking it. So this question paper, as an overall, I was feeling like there is not much more questions are like this, like pick right answer statements, true statement, like that. So okay, coming back to this question, Zeeman effect, you should be remembered, like it's a splitting of, you have 2l plus 1 degenerate states in the atom for a angular momentum quantum number L, that will split into 2l plus 1 non-degenerate states under presence of a magnetic field. This is called a Zeeman effect, or normal Zeeman effect, or weak field in the weak field limit. You have anomalous Zeeman effect in the strong field limit, which is not the question here because it's a normal Zeeman. So there are two types of lines actually, you can see. It's pi lines and sigma lines. You can see actually, if you Google, you can find out these details. The right answer is this. Actually, in the normal Zeeman effect, parallel to the field, sigma lines are visible, and perpendicular to the field, both sigma and pi lines are visible. This is one point you have to note down. This is true for normal Zeeman effect, but here actually the polarization is also asked. So the right answer, these are the answers. Sigma lines are perpendicular to the field, as I told here. Sigma lines are sigma lines perpendicular to field are plane polarized. Sigma lines perpendicular, it contains perpendicular directions, it contains sigma lines, these are polarized. And pi lines perpendicular field are plane polarized. So that means all the lines perpendicular to the field are polarized. Only sigma lines are visible parallel to the field. This is true. Okay, so these three are actually right answer. It's easy question. So it's a basic question you should be already knowing. Poly matrices satisfy. These are basically the commutation and anti-commutation relation written in some elaborate fashion. That's all. So the the commutation relation means this is a commutation between polys. They do not commute actually. This they have written down in this fashion, like sigma alpha. You can actually elaborate sigma alpha, sigma beta minus sigma is 2i sigma. That's the same thing here. And anti-commute, they commute, anti-commute. So any polymetrics you take, they anti-commute. And also, this is also there. If you square like sigma x square, sigma y square, sigma z square, this is identity. So these two relations they have combined into one in this. So this is basically sigma alpha, sigma beta plus sigma beta, sigma alpha, the left hand side here. And this should be equal to identity if there's a since this is identity, this should be identity, and this should be a 2 times identity here. Only when alpha equals beta, then you have all these three relations. Otherwise they anti-commute, it should give you 0 here. So this is the commutation and this is the anti-commutation. This is easy, should be my own. Okay, so for an op-amp based negative feedback non-inverting amplifier, which of the following statements are true? Again, true or true statement question. So negative feedback op-amp is basically you have the op-amp here. So you are giving some negative feedback from the output. It has both inverting and non-inverting inputs, right? So it's non-inverting, so you are giving input to the non-inverting input, which you should be remembering. It has 2 types of inputs, and it also have a negative feedback like this. So from the output, it takes some feedback into the system itself, in the amplifier itself, which is fed back to the negative because it's a negative feedback. Okay, so the point to note is that negative feedback, it decreases the gain and reduces the noise, and basically it stabilizes the system. Any negative feedback is a usual property for not only for op-amp but any amplifier you take, like the BJT transistor amplifiers also. They are usually used to stabilize the output. So the right answers are here. The closed loop gain is less than the open loop gain. You can actually check your if you have learned this in the textbooks or check Google. These are the right answers. And input impedance should be greater than closed loop input impedance is greater than the open loop input impedance, and the closed loop output impedance is less than the open loop output impedance. So these are the answers. The bandwidth actually you can see. So okay, this is not, I'm little okay. So this question maybe I will come back to this later. This particular option I'm not sure about. Okay. Anyway, the A, C, D are the options given. Okay. Do I have time for this? Okay. So yeah, maybe I will come back from this question onwards. In the next session I will come back. Okay, so thank you. See you in the next session.